Alright, so in this next video we left off here, and now I'm going to do some examples, and these are going to be a little bit quicker. We're going to kind of go through them and talk about where we're at. So let's look to this one. We call this a change of variables. So if we look quick and we say, okay, our inside is that, but this isn't really the derivative of that, right? So we say u is equal to 2x minus 1. We try to go through it. We do our best. We say, okay, du is equal to 2 dx. And we say, okay, great. And I don't really want the 2, so I'll divide that. So now I say, okay, dx right here is good. So let's see what we can do. So we get the integral of x, right? We got the square root, which is the outer function. And inside the square root is u. And then dx is du over 2. So I'm just going to du over 2 like that, okay? So now you get this extra x. This is called a change of variables because, yeah, it's a U-substitution, but there's a little more to it right there because now we've taken it to the second level because what do we got going on here? This x right here is not supposed to be there. And I don't really know what to do with it. So the only thing I can do with that is I can say, okay, well, what is x equal? So this is an extra step. This is an extra step, and it's a little tricky. It's not the worst, but it's a little tricky, where we got to take this, and we got to say that if we add u and we add 1 and we divide by 2, that's x. I solved this out for x. So u plus 1 over 2. So what happens is this becomes u plus 1 over 2, and everything else stays. So we still got this integral symbol, we still got the 1/2, we got the du, we got the square root of u. Sorry about the color mistake there, so I'll just do this. We got the square root of u. And now we're good. What do we do? I don't know. We can distribute it. We can do a few different things. This is 1/2, by the way. We lost a 2 there. What I would say to do in this one is to distribute the 1/2, the u to the 1/2. Let's make this a 1/4 there. I'm just going to stick with blue if that's okay. U to the 1/2 times u, so I'm distributing this 1/2. U to the 1/2 times u, because I took this 2 out to make it a 4th. Well, that's u to the 3/2, u to the 1/2 and u to the 1, so we add the exponents, u to the 3/2. You can pause and look back if you don't get that, but that's important to understand. And then here, this is u to the 1/2, okay, du. Not so bad because we can antiderive that. We can say it's 1/4, right? And we got these two things, and then we're going to add a c to it. So it's u to the 5/2 times 2/5 plus u to the 3/2 times 2/3. And this is our final answer. Oh, no, it's not our final answer because it's not an x's, right? So our x was 2x minus 1. So our u was 2x minus 1. So it's 1/4. It's 2/5, right? And then it's 2x minus 1 there. What is this? 2/3, 3/2. And then it's 2/3, and this is to the 3/2 plus c, like that. You know, our u was, I think it was 2x minus 1. So this is 2x minus 1, and this is 2x minus 1. Hopefully that makes sense. You can simplify, but you don't really need to. This is the correct answer. Or this is the answer that we can, this is an acceptable answer, okay? All right, so we're moving along pretty good here. Let's see what we want to do next. Next, we want to talk about this. So this is a formal change of variables, they call it. So it's kind of like U-substitution to the next level. Don't forget about this right here. So what did I do differently in this problem? It's this. We took the u, right, and we had to do this extra work to figure out what x was and then plug in. So that was made this a little bit trickier, okay, than the former U-substitution problems. We had an extra x to deal with. So they call it a formal change of variables. You rewrite the whole integral with du and du, but sometimes it's a little bit more to it. In addition, if this was a definite integral from like the integral from like let's say 0 to 2, right? You'd have to change. This is an x, and this is an x, right? When you're here with dx, but when you go to du, right? You got to put different x's. I mean, these aren't x's anymore. These are now u's, right? So it's u equals, and it's u equals. If this was a definite integral, I'm just putting these in as integral integration things. But what would the u, if x is 0, what's u? We go back here. If x is 0, u is negative 1. So you'd have u equals negative 1. You're rewriting the constant of integration. That's a negative 1. If x is 2, right, if x is 2, I'm over here on the left. That's 4 minus 1, that's 3. So you'd have u from negative 1 to 3. So what I mean is negative 1 to 3 of whatever u to the 3 halves plus u to the 1 half. And we're looking over the side. Now everything there is a u. There's no x's there. This is a u. This is a u. These are all u's. So that's kind of a little bit of foreshadowing there, but we're kind of getting into what we're trying to talk about there. So another example maybe, and then we'll kind of take it down. These are all the guidelines. This is probably good for you to look at, so you might want to pause and take a picture of this or something. It's an option. But I'm going to keep going. So if you want to just scroll back and pause and look at that, that's great. Here's a trig one, okay? Which one's the inner, which one's the outer? It gets a little weird. We're talking about transcendental functions, anything that's not a polynomial or a rational. If it's like a sine, a cosine, a secant, a trig thing, exponentials, logarithms, those are called transcendentals. All right, so let's try to do this problem here quick, or at least get a little bit of guidance. Take a look here. We're talking about when you're making a change of variables, you want to make sure that you use the same variables as the original. So in other words, what they're saying here is that you want to make sure you change back to whatever you started with. So in other words, what this means is go back and write your answer in x, right? So back to x for your answer. So just don't forget to change back when you're doing that. So here I see sine of 3x and cosine of 3x, but sine of x is squared. So like when in doubt, pick the u to be the inner, and this sine is all squared. So sine of 3x is your inner. You can't pick just 3x to be your inner because there's no like just a 3. There is a product here. So U-substitution is pretty helpful with products in particular, and they're really, when you see a product there, that's a function and its derivative. So I can't say that enough. An inner function and usually a derivative of that inner function. Not always, but these are the rules that can kind of help you. So now our du, and we don't do du dx anymore, we're just kind of skipping over that, is cosine. Leave this alone. Chain rule it. And that's going to have the dx on it. Sorry, handwriting is not great here. So let's zoom in here. Okay, so you see that there's this 3 here that doesn't really seem to be showing up here. So I'm going to divide it to kind of just get it out of the picture for a few. So if I divide by 3 on both sides, I have kind of what I need, which is this. So what I'm seeing is the u is this, the du is this, there's something still missing of course, and the outer function is the squaring function, because basically this is sine of 3x all squared. Okay, sorry, that's sloppy. So now I'm going to rewrite my integrand, and hopefully you can maybe you can even substitute and get the answer here. So it would be a good time for you to pause the video and just try this problem. And then as a word of advice, you might have already known, you're looking for this answer in the end. So see if you get this answer over here, because that's what you're looking for. But then you change it with a sine of 3x. So I think you want 1/9 sine of 3x to the power of 3 plus c. So that's your answer. So pause the video and give that problem a shot. Hopefully it goes well for you. And then once we are through that, we're kind of to problems with either that extra x in it, talking about how we check them. These are just all sorts of examples that we can do in another video, and that will maybe not be indexed here, but it will just be a video with a whole bunch of examples. So there's a lot of things we can do with it, but I wanted to kind of show you how this can happen. We can have a definite integral, and these variables are x, right? These are x's because this is dx. We want to change it to an integral with a u, and then have a du. Okay, so I'm going to stop there, even though I was kind of scrolling around and getting ready for some other things. This is long enough. I will see you in the next video. Peace.